Diffraction. One property of all waves is diffraction. This is where waves spread out at the edges, or diffract, when they pass through a gap or go past an object. Let's look at some water waves from above. We can see the diffraction happening here. If we set the gap much bigger than the wavelength, we don't get much diffraction, just a bit of a spreading out at the edge. But as we decrease the size of the gap, we get much better diffraction, until the gap size equals the wavelength, when we get maximum diffraction. It should also be obvious that we could have increased the size of the wavelength, leaving the gap size the same, and that would also have improved diffraction. The main thing is we get the gap size to equal the wavelength. So this is great, but is there a practical use for this? Well, there is. If you lived near a big hill, you might have problems getting TV or radio reception, as the waves would be blocked by the hill. But because of diffraction, the waves spread out when they pass the hill and can be received by your aerial. However, the really short wavelength signals will still miss, but you'll get the longer wavelength ones. So in summary, diffraction is where waves spread out at the edges when they pass through a gap or go past an object. And diffraction happens best when the wavelength equals the size of the gap.